In this video, we'll be looking at Theorem 10.2, and as it says, the lengths of tangents drawn from an external point to a circle are equal. Alright, so firstly, what does a length of a tangent mean? A length of tangent is equal to the segment that joins the external point and the point of contact between the tangent and the circle. So basically, segment PR, the length of this segment, and segment PT are our lengths of tangents, alright? And we have to prove that these lengths, that is PR and PT, drawn from an external point to the circle, right, with center O, they are equal. So we have to prove that PR is equal to PT. And I like to follow the given to prove and proof format. So let's begin with our given. Okay. This is very easy. Actually, you have to draw your own diagram in which there is a circle. You can give it any center. You have an external point and just draw two tangents from them to the circle. So in our case, I'll say that given that a circle with center O, tangents drawn to it from external point P, and we have to prove PR is equal to PT. Now, how are we going to prove this? Let's give it a thought first. Now, from what we can see, that if we join O, right, to T, and we join O, R, O, P, we get two triangles. What are those triangles? Triangles PTO and triangle PRO. So two triangles are formed, and somehow if we can prove that these two triangles are congruent to each other, then probably by CPCT we can prove that PT is equal to PR. Now, how can we do that? Firstly, I know that OT, right? OT and OR are the radii, so they are equal to each other. So also, by theorem 10.1, the radius is perpendicular to the tangent. So OT is perpendicular to PT and OR is perpendicular to PR. And so now they are right angle triangles because there's at least one angle which is 90 degree, okay? And if these are right angle triangles, they have a hypotenuse which is OP, right? So OP is the hypotenuse, and since it is common to both the triangles, we have a pair of hypotenuse which is equal to each other. The radii is a pair of sides which is equal to each other, and a pair of angles which is 90 degree. Therefore, by the RHS, we can prove that these two triangles are congruent to each other, and therefore our lengths of tangents PT and PR will be congruent to each other. Okay, so let's prove it. So firstly, begin by join OT, OR and OP. OT is perpendicular to PT and OR is perpendicular to RP by radius perpendicular to tangent, or you can also write theorem 10.1. Therefore, triangle PTO and triangle PRO are right angle triangles. Okay, and let's write down our test of congruency. I'll begin with a pair of right angles. Angle PTO is equal to angle PRO equal to 90 degree. OT is equal to OR because they are the radii. OP is equal to OP, common side. Therefore, triangle PTO is congruent to triangle PRO by RHS, and therefore PR is equal to PT by CPCT. Hence, proved. And there you go.